Hey class, Mr. M here with a homework example. This is not from the homework, but it's very much like a homework problem. Let me actually add something here that I forgot to add. Sorry about that. Now it looks more like what you have in your book. You have a function, you have an interval, and you've even been given an estimate as to how to subdivide that interval. Alright, so let's see how we can begin. A graph will always help for these when you're finding the area under the curve. Now, remember, we know how to find the exact area under the curve, but that's only because I've told you, right, that you do the integral thing with the numbers on it, called the definite integral, and that gives you the area. But we'll build to why that actually works a bit later on. But for now, we don't know exactly how to find the area, so we have to do this approximation method. So I'm going to graph this, and I'll put a better picture in the next slide so we can do the math on the same picture. But this is a parabola, right? It's an upside down parabola, and it's got a y-intercept of 6. Put that right here. And it's pretty wide because it has a -1/2 and it's facing downward. So something like this. -2 is somewhere over here, and 3 is somewhere over here. So we're trying to find, right, this area. Oops. We're trying to find this area right here. How much space does that take up? Right? And there's obviously no formula for that. You can probably figure several different ways to subdivide it, but there's no clear way to understand exactly how that comes about. So that's where these rectangles will come into play. And the problem has even told us that we want to split this into 5 rectangles. Right? And if you read the instructions in the I didn't have space here to write it because this doesn't allow me to type, but in the book it says use left and right endpoints to find 2 approximations. So I'm going to walk you through those 2 methods in this video, the left and the right. Because they give you different values depending on how you approach it. So the first thing to figure out actually is how are we going to subdivide this interval from -2 to 3 into 5 rectangles. Well, you can probably already figure it out, but in general, the width of your rectangle, which is going to be the base of the rectangle, which is a delta x measure, is going to be b minus a over n. Right? And that's something you can memorize if you want to, but you really want to understand why this is happening. We have something that's ending at 3, right here, and we're finding the distance across the entire interval. This interval is 5 spaces long, right? 3 minus -2 is 5 on top. And we are dividing it, right, 5 ways. So 5 divided by 5, of course, is 1. So each of our intervals, right, is going to be 1 unit long. That's all that we've just figured out. Delta x is equal to 1. Right, you can really see why it's called delta x now, because we literally have, right, draw that better, we literally have these widths along the x-axis. So here are our 5 rectangles, and they're not really rectangles yet because we don't have heights. Sorry, we don't have another base, so this will be a rectangle, but we don't know exactly yet how to make those. So just to visualize this, we're trying to find the areas of these rectangles, and then we're going to add them up, just areas based on side. Alright, so now that we have that mental picture, let's get a more sophisticated picture on the next slide. Okay, so I went ahead and drew the curve here, and I have our intervals very clearly marked, right? 1, 2, 3, 4, and 5 spaces here. Now, if you notice in the book, it tells you to use the left and the right endpoints to make your rectangle. So what does that mean exactly? Well, I'm going to look at this first interval, which is from -2 to -1, right? That's our first, remember this is from -2 to 3. I'm going to use 5 rectangles. So that first window, well, there's 2 numbers we can use, right? We can make a rectangle like this. That's one possibility. Or we can use a rectangle like that. It depends on which number, -2 or -1, you use to make the height, right? So since this tells you the left, all you got to do is use the left number, which in this case is -2. So there's my rectangle. Here in the next interval, I'm going to do this one in a different color, right? That's this right here. From -1 to 0, what's the left number? The lesser number, it's -1. So I'm going to use that to make my rectangle height. Right? The base is delta x. We already have the bases all equal to 1. It's the height that's the question. And the left rectangle, sorry, the left endpoint approximation tells you which value to use. Not the left, not the right, not the one that's more, but the one that's less. Alright, so from 0 to 1 here in green, 0 is the left number in that specific tiny window, right? So use 0 as the height. Let's see, from 1 to 2, obviously 1 is the lesser number, so use 1 as your height. And when I mean the height is, I mean the y value at 1, right? So this is the point 1 comma, so this point right here, right, is 1 comma f of 1. So, you know, that will tell you what the height is, because you're using that number, not the 2. And for the final rectangle, right, it says to use 5 rectangles initially. Let me choose a different color here, use purple. We're going to use the left endpoint, which is 2. Alright, so there we go. Did I use the rainbow colors? Red, orange, green? Kind of. Interesting. Alright, looks pretty. Fair enough. There are our rectangles. Now all we got to do is find their areas. Well, the areas of each of these rectangles are pretty easy to find. Right, this first rectangle, which I'll just call it A, its area is the base, which is delta x, times the height, which is, well, which number did we use to figure out what the height was? We used -2. That was the left endpoint. So how do you find the y value or the height? How long is this thing that I'm outlining here in red? How long is that? That is the y value at -2. Right, remember, delta x is just 1. And since we already know all of these delta x's are the same, right, they're all 1, it's all going to be area is base times height. Right, so all of these bases are going to be delta x. So they're all going to have that delta x. So what I'm going to do, just to clean things up a little bit, since we're kind of getting the hang of this through some more practice and some videos, is I'm going to just factor out the delta x. Right? All of these are going to have that. All of these have a base of delta x, delta x, delta x, which again we've established to be 1. Right? So I'm going to go ahead and replace that with 1. Again, that's delta x. Alright, so I'm going to try to color code the rest here. This rectangle here in yellow, right, let's call that B, its height was dictated not by 0, which would be up here, right? Whoops. Right here. No, not there, but rather the left endpoint, which is at -1. So plus f of -1. That's where this rectangle's height came from. Plus f of 0. Not f of 1, but f of 0. The next one's height came from f of 1 because it was the left endpoint in that interval, right here. And finally, the last interval, right, its endpoint comes from the 2, not the 3. That's what it means by left endpoint, right? So this is your base right here. And we're just sort of distributing it, right? Base times height, base times height, base times height. So we factor out the bases because they're all the same, and you're left with all these heights added together. And these will give you the individual areas of the rectangles. But of course, when you add them all up, you'll have an approximation for the entire shape. So I'm going to pause the video and go ahead and calculate this here. What I'm doing is I'm taking each of these values, right, and simply plugging them into the function, which is, remember, y equals 1/2 x squared plus 6. So just plugging it in and seeing what the output is. So I'm going to pause it here and fill those in. Alright, so we're back, and I filled in these values. What I did was, just to show you, a technique here to save you some time, I just plugged this function into my y1 in the calculator, and I looked at the table, right, and it went -2, -1, 0, 1, and it just gave me all the y1 values. So that's where these came from right here. And if you add these all together, right, you will get 25. And those are all the bases. So all the heights added together times all the bases, which are all 1, will give you an approximation for the area to be 25 square units. Units squared. And there you go. There's your left-hand approximation. Now, what's the right-hand approximation? It's very much the same. Right? So I'm going to pause here and make a new picture. Okay, so here's our intervals, once again, in our function from -2 to 3. Now, in each interval case, right, the delta x is still 1. We're still using 5 rectangles, but we're now going to use the right endpoint in each tiny interval to dictate how high it is. So this is our base of the first rectangle, right? And rather than using the left value, -2, I'm going to use the right value, which is -1, and there's my new rectangle. Right, so here's the second one. I haven't made these equally spaced, but I think we'll be okay. I'm going to use 0, not -1. in the next case, I'm going to use, in this interval right here, what's the right value? That would be the 1, right? It's the bigger number. So that's going to be your rectangle. And in the next case, we have from 1 to 2. The right value is 2, so that will dictate the height. And in the next case, we have 3, right? And that will dictate the height. Oops. There we go. Y value, there you go. So, actually let me try to make this a little more accurate. From 2, go up, there it is, and from 3, go up, and there it is. Okay. So contrast this picture with the last one, right? They sort of have different bars, even though they're covering the same space. So it's going to give you a different approximation. But the method is still exactly the same, right? Your bases are all the same, so you're going to factor that out. So delta x equals 1, so there's your base, times distributed all the heights. So I'm going to fill these in real quick. In the first interval, what calculated the height? Not the left value, -2, but the right value, which is -1, plus what calculated the height in the next interval, right here, that would be f of 0. In the next interval, it's f of 1, right? From 0 to 1, the right value is 1. From 1 to 2, the value would be f of 2, right here, that's the right value. And the final interval from 2 to 3, the right value is f of 3. Right? So that's 1, 2, 3, 4, 5 heights times all the bases are the same, factor it out 1. So I'm going to go ahead and pause once again and fill in these values for us. Alright, so once again I plug this into the table, right, and I found what those values were. I plug each of them in to the function, and just to give you a visual understanding of what this represents, that means that the base of this rectangle, right, is 1 unit. The height of this rectangle is this line, this length right here that I'm outlining in red. Well, how long is that line? Well, that point right there is -1, 5.5, right? This is plugging the function in to the original, the point of the original function. Well, that would be your height of the rectangle. So base times height is the area of a rectangle. So that much space, right, is 5.5 times 1, or 5.5. Likewise for the green, likewise for the orange, and so on. So when you add these all together, right, what you will get is 22.5. That's the sum of all the bases times the height, which is all 1. Sum of all the heights times the base, which is 1. And you'll get an area of 22.5 square units. A different approximation gives you a different estimate, right? A different value, because of course our shape looks slightly different.